Welcome back to Spring into Discovery Space for our fourth webinar in the series. This one will be presented by myself, Michael Gregory, from the European Physical Society. And it's on the learning scenario, Zookeepers of the Galaxy, which I'll explain more in a moment. But first, I'd like to introduce my co-host, Louisa, who's joining us from Nucleo. Thank you for joining us again, Louisa.
You're welcome. It's really nice to be here with so many people.
And so Louisa will help me keep an eye on the chat and things like that. If you have any questions as we go through things, feel free to interrupt and use your microphone. There's not too many of us, so that shouldn't interrupt the flow. And my background is teaching, even though now I work at the Physical Society as a teacher trainer. I have 15 years of classroom experience, so I'm used to being interrupted all the time. And I actually kind of feel lonely when people aren't interrupting. So please don't be shy if you have something to say, or if you prefer to put questions or feedback into the chat, then either Louisa will interrupt me or reply in the chat herself. Kind of whatever seems best for questions as we go along. As we're getting started, please feel free to say hi in the chat, especially if you mention where you're joining from, because it's always exciting to see people joining from different countries. As you hopefully start saying hi like that, I'll get into a couple of reminders about the webinar series and then into details about Zookeepers of the Galaxy. So as a reminder, this is part of the whole Spring into Discovery Space campaign, which includes this webinar series. This is webinar number 4 of 8, if we include the finale. The finale will mainly be to announce winners of the implementation challenge. So that's why the date hasn't been set yet for that. And we won't be going, it'll be a shorter one, the finale one. But all the others are going through one of the learning scenarios, or the very first one, the platform itself. So if you feel lost what the Discovery Space platform is, if you weren't in that one, the recording of that and all the other ones are online as well, so you can check those out. Also to mention or remind the implementation challenge. So this should be an exciting incentive for teachers from Erasmus Plus countries to participate in testing this out. Teachers who are teaching beyond the Erasmus Plus zone or list of countries are still very welcome to use Discovery Space, participate in the webinars, but unfortunately the funding won't cover you for prizes. There's a couple of specific cases, like teachers teaching outside of their home country. We're looking into responses for that. I still haven't gotten a clear answer, but if you have any questions like that, please let us know and we will look into those. Again, the first prize, and there's up to 10 teachers who could win each prize, is a funded trip to Marathon, Greece, the second week of July for the Discovery Space Summer School, which is a week-long course going into detail about Discovery Space. It's part of a bigger summer school event with exciting speakers. It's a nice place by the beach too. It's a really good prize. You should get excited trying to get that one. Second prize sounds less exciting. Mulhouse, France. That's where the European Physical Society is based. There's no beach there. But it is a nice town, and it is the headquarters of the European Physical Society, where we'll be running a Discovery Space workshop. So I would be excited for that, because I love physics. I love the Physical Society, and I'll be the one running that workshop. And then third prize is Discovery Space training individualized at your school in your area. And that would be likely me or someone else from the Discovery Space team would plan a training event for you based on your needs and desires. And all of that is based on how many times you implement Discovery Space scenarios with students. And there's a little bonus, 7 points as well per webinar attending. So if you're here already, then you've got 7 points if you're participating in the challenge. But theoretically, if you stay for the whole webinar, but just going to look at who was at the webinar. So that's that. Next, I'm going to give you a link to these slides in the chat. The reason for that is because I'm going to be giving a couple more links. So if there's anything that that I miss relaying into the chat, or if it's handy to have everything for later when you look back, here's these slides. This is only the 4th slide, so I mean, look ahead if you want. But the next couple of slides will all have links that I'll be relaying in the chat. So usually I find it handy to have everything accessible in one place, especially if you're looking back afterwards to do it. So then you have all the links together and you don't need to worry about saving the chat. Okay, so without further delay, we're going to get into the Discovery Space platform, and then I'm going to talk you through kind of the learning goals and the theory behind the Zookeepers of the Galaxy learning scenario. So to access the platform, and some of you who have participated already in some of the webinars or some of our workshops we've been running in person and online across Europe will already have logins for this. But in case some of you don't, I'm going to walk you through this again. Just getting out of the slides so I can copy these more easily into the chat. Also, as I'm doing that, please give a reaction. So like Zoom reaction buttons at the bottom, you can give a thumbs up or wave, or, you know, there's a couple of reactions possible. Give a reaction, any reaction of your choice, to indicate if you have already been on the Discovery Space platform. So then Louisa and I can have an idea how many of you have already been using it and how slow to go mentioning how to create an access. Okay, so there's a couple of reactions. I should have been more clear. What I meant is any reaction means you've connected, but a raised hand could mean you have a question. If you have a question, please ask it. But it's good to see that some of you have already been using it. After last week's webinar, I heard from two of you by email for feedback having used it. And that's the number of emailed us. So hopefully that's indicative that there are even more who have been using it. For those of you who haven't yet been using it, so if you go to the link, which I copied in the chat, you'll get to the login page. Oh, the login page is this part. And if you don't yet have an account, and if you have an account, go straight in there. Ignore the next 15 seconds of what I'm saying, because you don't need it. But if you don't have an account, go to the create an account section. First name, last name, email, your username. We're recommending, and it's useful if you use your email address for that, because it's easier to keep track if you forget it. But also, if you're participating in the implementation challenge, it'll be easier for you to tell us who you are and not mistake you for someone else, like if you choose a random username. But I mean, it's up to you. You could use your email address or your name or something clear. If it's not clear, we might not know who you are if you want us to keep track of your implementations for the challenge. So you've been warned on that. The access code, you'll need to copy paste it in there. I have it already ready to go, but I'll get an error if I try and create a new account. Well, I haven't filled it out yet either. But that's how to create an account. If you have problems with that or questions to ask, please ask before we move on, because as I mentioned in the email I sent out about the webinar, a chunk of time during this webinar will be spent having you try out the scenario. So if you can't access the platform, then it will be very hard to follow along. So please let us know if you have any problems. Okay, so back to the login. Hopefully everyone now has a login and you can log in. You're greeted by the dashboard. I'll go through some of the things with the dashboard at the end, but now I'm going to skip to the authoring tool. Hopefully you're connected. Feel free to follow along so you can see what I'm seeing. You'll see a slightly different version because I have access to all of these private ones, private and organization only learning scenarios. You'll only have access to the public ones. That's just sharing details, mainly for things that are in progress. But one of the ones you'll see will be Zookeepers of the Galaxy V2.25, which is just the version from February 2025 onwards. I have about 3 other versions from iterations of different places I was using. For example, this one was a version I'd made for workshops in Spain. Note that it's in English because during the development process, I've been developing everything in English. And as I'll show you when we get to student view and trying through, you can use a built-in translator in your browser to machine translate scenarios. So it makes sense to have a limited number of versions and rely on machine translation. Even though the translations aren't perfect, they're a useful way of having a limited number of versions and accessibility in a large number of languages. Hopefully it'll become clear once we go through a couple of things on machine learning and how AI works, why it's useful to have a limited number of versions. Other than, of course, for the development process, if we make changes to one version, then we want to make changes to the others as well. But that's an internal rather than a structural issue. We have a question
Yes.
coming in the chat.
Yes, it's from a Portuguese teacher. Hello, Anna. I think Anna was at our Portuguese webinars.
Yes,
and
I was, but
yes.
I have this account. I'm not sure if it's a teacher account or
No,
a student's account.
that's a student account because
Okay.
in Portugal we had 2 sessions. The first session we gave student accounts to the teachers so that they would experience being a student. And
Okay.
then on the second session we taught how to create a teacher account, and that's exactly what Michael did now
Oh,
at the beginning.
Okay,
So
okay.
this was
So
just for you to test as a student the
mhm.
scenarios that we chose, but now you didn't
Okay.
didn't you create a second account
Yes,
afterwards?
I was in the
session?
second webinar, but I'm not sure why my computer did not. I don't know, but
Probably,
I
yeah,
will
you
do as Michael told
said
us.
yes.
Okay.
Probably if you did have if you did create an account, you can try, and since we told you to use your email, try logging in with your email, and probably
Okay.
you
Okay.
have
Okay.
a password that you always use.
One where we tested an older version of Zookeepers of the Galaxy, and you all had student logins for that. So if your computer remembers a student login for that, it's better to create a teacher login today.
Yeah.
Most of what we'll go through with testing, the student login will work, but to actually use it with groups of students, which is what we're encouraging you to do now, you'll need a teacher account to do that. So it's better to create a teacher account.
Yeah.
And I'm just going to log out for a second to show you if you forgot your password. Often if you accepted an auto-generated password, it'll have a bunch of random characters. You won't remember it. So unless you have a password, forget the name of it, the thing that saves passwords.
Yeah,
the
it's
password
like a
wallet, password manager,
chain
password manager, I think.
keeper.
Anyways, like if you lost your password, there's the password reset button there. So if you click on that, hopefully, yeah, then you can enter your email address. As long as you're in the system, it'll reset it. If not, then use your email address to create a new account. So hopefully that should sort out any issues people have with that. But if there are more issues, please don't be shy to ask, because really we're trying to encourage you to use this, and we're here for you if there's anything we can do to help out.
Definitely.
Okay, so back in the teacher view, I've gone to the authoring tool, which is the second thing in the menu on the left, and I'm going to Zookeepers of the Galaxy v2.25. That it's the only Zookeepers of the Galaxy that's public that you'll see, and go to the view part so that we can see the guts of the scenario. And I'll be pointing to it, but feel free to go over different parts of it. Click around, explore. But to explain kind of the theory behind the learning scenario and the different phases that we have. So this learning scenario was one that I created in the fall, and in Discovery Space, to have the platform available, there were some delays. So it wasn't certain whether we'd have a usable platform before I was supposed to start running training for teachers. So with my boss at the European Physical Society, we discussed different options and what we could do. And the plan was to come up with training for artificial intelligence, which is one aspect of Discovery Space that we could use whether or not the platform was ready. In the end, the platform ended up being ready in September, and there were still a couple of bugs being worked out through the fall, but it was useful to use what we had done to have tools to help teachers teach students about artificial intelligence. So some of the scenarios we've been working on focus both on an area of a science curriculum, in this case, Zookeepers of the Galaxy. It's with galaxy classification, which only comes up usually in an advanced physics course in an astrophysics option, but it's actually quite an easy concept that could easily be handled by middle school students. It's just that there's not much you do with the identification. But in this context, the learning scenario was created with the idea that you could either use it with advanced physics students who need to learn about galaxy identification, or with younger students as an add-on activity for learning about space, but then bringing in concepts of artificial intelligence and machine learning, because it takes students through how to train a machine learning model. So there's a couple of steps to that are laid out in these phases. And notice once you're in this view, if you click on any of the boxes here, it'll bring you to that activity. So here, the engagement phase, this gets students into the activity. Those of you who participated in an earlier version of this, you'll notice the engagement phase, well, you might notice the engagement phase is much shorter than before. And that was because both in Aimlo and in Cuenca and in Burgos and a couple of places, it seemed to take a little bit long to get to the experiment phase where students were actually training the model. So then the first parts have been shortened a little bit. So it starts, some of the earliest activities are just a matching activity. And this is the authoring view of it. So matching to figure out which of these two pictures fits within this set of pictures. And we'll actually do that now as an activity. So hopefully you can see my screen well enough, and I don't need to change the view. There's 10 pictures up here, and there's 2 pictures down here. And without any other information, and this is starting with learning how to identify by looking at similar patterns, similar as how kids learn how to explore the world around them. And that's an element of how a machine learning algorithm learns as well. Rather than telling it what to look for, it's just looking for patterns. So based on what you see in these pictures up here, does picture A or picture B fit that pattern better? Write in the chat your guess whether A, the top picture, or B, the bottom picture, better fits into this. We have one answer, but let's see if we can get a couple more guesses.
Getting another one? Yeah. Anyone
Okay,
else?
so
Yes.
okay, now we're getting more answers, and maybe it's just people are shy to say something different than the others, but it seems like people are agreeing that it seems to be A. And
Isabella also thinks it's A.
Some of you might be familiar with spiral and elliptical galaxies and be able to name it and give more details, but just looking at a pattern, most people are able to identify what kind of galaxy this is. So that's the goal of the engagement phase in this scenario. Now, if I go back, back, it doesn't always like using back in your navigator, but usually kind of works through. Okay, so the hypothesis phase then goes into more detail, actually giving reasoning behind why the different types exist. So and you can see it gets a little bit messier with pathways depending on whether guesses were correct. There's a shorter pathway if students correctly identify them, but then they all get to some common ones about classification. Like this one, I lost which one I wanted to go to. The one that gives the Hubble tuning fork. Yeah, I think this one where two of them. Got lost in my own scenario. But anyways, this goes through a couple of questions where they're asked to classify based on one and another, whether it's a spiral galaxy or whether it's an elliptical galaxy. So through this phase, students should learn not only to identify based on patterns, but then to identify what the patterns are. Like a spiral galaxy will be have rotational symmetry, whereas an elliptical galaxy, well, no, they both have rotational symmetry. A spiral galaxy shows traces of rotational motion, is what we're looking for. And then they'll see the iconic Hubble's tuning fork diagram. Then the experiment phase. This one is where they actually shift from student learning, student identifying types of galaxies, to how to train a machine learning algorithm. And there's two main options here. You can see this one skips all these steps here, and this is how to get the data from the data that they're going to use, which in this case is a subset of the Zooniverse, but it's Galaxy Zoo database, which is part of the Zooniverse Citizen Science Initiative, which is one of the world's biggest and longest running citizen science initiatives. And the idea behind citizen science, and hopefully you're all familiar about this and using different citizen science initiatives with your students to engage them and have them play a role in science as well. But one of the ideas behind citizen science is when there's more data than the researchers themselves can handle, then to outsource it, to crowdsource some part of analysis to volunteers who want to help out and be a part of the investigation. So this is very popular in ecology. People love looking at pictures and videos of animals. So like one of the base models for a citizen science initiative could be with a webcam at a nature reserve. And the webcam can film 24 hours a day. No researcher has the patience or the time to watch 24 hours of footage. And so they put the live stream onto a website, and they say, if you see something interesting happening, if it's an animal going to drink water, if it's kind of any animal or any activity you could imagine, then you can click a button, ring a bell, do something to flag that part of the recording as something's interesting is happening here. So there's some people who will spend hours just watching these webcams and clicking, and they're participating in an aspect of science. Galaxy Zoo is similar, but it's with telescope pictures of distant galaxies, many of which are being shown for the first time, just because the power of telescopes has outpaced the I guess the human power to look at telescope images, or at least in the astrophysics world. And that was something that really came to be with the Hubble telescope. And in recent decades, that the amount of data that was being taken was bigger than any number of humans in the field could analyze. So they decided to create a website where volunteers would be shown images of galaxies and asked to classify elliptical, spiral, or unknown. Or like the third category is like unknown or weird or maybe not a galaxy. And so there have been over 200,000 people who have participated in this. Millions of galaxies which have been identified, and scientific papers which have been written even with new types of galaxies that were identified from the weird unknown bin. The P galaxies, because the green dots on the image made it look like they were P's. And when there were enough people who identified that, then they said, well, this isn't just noise. A lot of people have identified something that looks like a P. Let's look at what these images are. So it's a big citizen science initiative, lots of data, 3 gigabytes of data. If you choose to compile code yourself, then you'll be taken through steps. And I'll show you this. This is recommended only for very ambitious students who already have some knowledge of coding and like coding, although it takes through step by step. So you don't need to have background knowledge in it, but it takes a while. So it's recommended just to download one of our much easier to handle. Yes. One of our much easier to handle pre-made data sets. So that's the data download. Here, where there's a folder on Drive and then different images with 50 images per folder already organized. So both are the options there. But the goal of that phase is to get the data to prepare to train the model. Next, in the analysis phase, well, actually, yeah. I realize I'm talking a lot and I want to get to you trying out in the student view to test things out. So I'm going to go really quickly through the analyze and reflection phase. So for analyzing, the idea is analyzing the impact of having a different size of data set on your training. So training the model with more images, with less images, seeing how successful it is at identifying what kind of galaxy it is. And that's kind of like the base how you train an image classification model. Then the last phase, to reflect, involves 2 things. One is changing the number of training epochs, which is the number of times the data is presented to the model and running through, but then trying to understand what that means. And that's where there's a deeper reflection involved there, because any machine learning model will be a balancing act between processing power, or how much you're asking a computer to do, which then relates to how much energy it uses and how many available processors or how much processing time, versus the accuracy of the model. And so when a model's created, you'll want to optimize to have the minimum number of processes that are completed to have an accurate model that can, in this case, correctly identify galaxies. And then ends with an activity going back to looking at some galaxies, trying to identify them by hand and comparing that to the machine learning model. So testing whether the student has become better, worse, or the same as the model that they have created at identifying galaxies. So that's an overview of what all is involved with it. The next step that we're going to do, I'm going to ask you to go into the student view and actually try it out, because if you're like me, and maybe you're not, but some of you are bound to be like me, then I'd want to test something out and see how it works before ever giving it to students. And so rather than asking you after the webinar, go home, test this out. If you have problems, let us know. We're going to do that live, which means once I turn things over to you, I'm largely going to stop talking for a while, which will feel really weird to be in a webinar, and I'm not talking unless you ask me a question, but I'm going to give you time to work through the scenario. So in the student view, please go to the student view now, and luckily you have less options than I do, so it will be easier to find the right one. All the way near the bottom for me, Zookeepers of the Galaxy. And we're going to start this. And I'm going to show you the first 2 activities, and then tell you to go through on your own and update me as you go through. But before I get into so this is why I'm showing you student view. There's 2 options: start and restart. If this is your first time connecting to this scenario, your login, start just works fine. But once you work through the scenario, the platform will save your progress, where you've gotten to. So if you disconnect, if you reload the page, if you stop and you connect later, it will usually remember where you progressed to. And so this can both be handy, like if you end up accidentally reloading the page, or well, reloading the page intentionally or accidentally, or if you need to take a break and get back to it later, even though the learning scenarios and the platform have been designed such that it's recommended to go through a whole scenario at once. It's not a good idea to stop and come back to it. But I mean, it messes up some things with timing. But if for whatever reason you have done that, or you've reloaded the page, restart will clear that data, and you'll start at the beginning. Start. I don't know if I've restarted or if I'm going to be in the middle, so I'm going to try that to show you what it looks like. On the second part of engagement, so I'm only a little bit into it, but if I go to restart, then it'll start me at the beginning. And that's useful to know also, and this came up in last week's webinar. It's not possible to navigate backwards through the scenario. That was a design choice by the design team making the platform. But sometimes you'll realize on one activity you missed clicking somewhere, or like you should have clicked on the other button. So if you reload the page, then it'll go to the last save point, which is usually about 2 activities previous. So it's a way of kind of messing with the system to get back. Okay, so I'm greeted by Plato. He's the chatbot who guides me through. So he's the one, like, that's where I'll put any answers. I'll say to continue. And now we're showing the images, and notice the chatbot blocks the images. And if you're in one of my trainings months ago, you might be surprised it still hasn't been fixed yet. It apparently is not a priority to have it not block some things, but if it blocks parts of it, 2 of the solutions are resize your window, and now it seems to work. Also, if I make the window really small, the chatbot will be below rather than above, and I can scroll side by side. So it's, you know, it's slightly awkward, but it is possible to get around that. Or if you resize the window, so I'm going to mess with my zoom levels, and there now the chatbot is at the bottom. If I then zoom out again, we also get to like yeah, now it's not blocking. So like there are different ways playing around with the settings there. Okay, I think I've talked enough, and it's time to encourage you guys to go through the scenario for a little bit. So it feels kind of weird doing it where people are going through a scenario and I'm not talking anymore. So I'm going to ask you to update me every once in a while. So after a couple minutes, I'll say, okay, can everyone send a screenshot to show me where you've gotten to in the activity so far, so that I see that you're following through. If people got stuck, then I can address issues like that. So I have this form created to share a screenshot. Screenshot is the only thing you need to put in the form if you don't want to put more. If you want to put your name, so I can say, oh, it looks like Louisa has gotten to this spot and has said there's a problem that she got to there. Then I can identify you. But if you want to do it anonymously, the only thing that's required from the form is to share a screenshot. I have a link for that in the slides, which I gave you a link for the slides because I said there would be because I said I would. And now in the chat, here's this form. So I'm going to ask you now, take several minutes to start progressing through the scenario. And once you've gotten to, let's say once you've gotten into the scenario, share a screenshot via that link so I can see that you've at least gotten into the scenario, and then keep progressing through the scenario. And we'll take about we'll see how it goes. I'll give you at least 10 minutes, so you should be able to get through the engagement and hypothesis phase, and then we'll see how it's going if it's worth giving you more time to go through the later parts of the scenario.
Just to make sure, is everyone able to see the student view of the scenario? Yes? No one has any problems, no? Okay, if anyone has any problem, please let us know.
So now I'll be quiet for a couple minutes unless or until there are any questions. And I see there are some questions. One both in the chat, and another one I've gotten with a problem with the form, which I'll try and resolve. But the question about the folder for the step, that one should be the folder to download the images. The link was given in the activity just before that. But if you missed that, I'll paste that in the chat now in case that's useful. And if that happens to students as you're going through the scenario, you can have them, well, and if you want, you can try it now actually as a solution. You could reload the page and it should skip you back 1 or 2 steps, so you'll have the link again. But it should be, I was just navigating to find the link.
I have the drive, but in the drive we have a lot of I have test images and then zoom in inverse ISS 1, 2, 3, 4 until 8.
Yes, so you download one subfolder of it, and that's the last sentence. It says choose one and download only one
Only
Zooniverse
one.
ISS.
Okay.
Yeah. And,
okay.
And the reason for that is just so that students could have different ones, so they can see no matter what data set they train it on, they should have similar results. So that's why there's 8 different data sets of images, but it's just number 1 to 8. So like pick any number.
Okay.
But Mike, when you are testing verification 1, you ask how many images are in the folder of spiral galaxies.
Yes, and it gives a number of options, and anyone who's downloaded the folder should know that there are 50, and so they'll that verifies that they've actually downloaded it.
But you only know that after if you and it's written spiral.
Okay, so that's a typo that I should definitely fix there. But the idea for the verification loop that came up because you can't go back, and it was a problem like Carlos mentioned last week. If students aren't instructed clearly, they might just try and click on things, getting from one step to another.
Sure.
And so the verification step was a way of sending them back to a copy of the download if they don't appear to have downloaded it. So I forget, I think I had 2 verification questions. One was the number of images in the folder, and the second one, oh yeah, the average file size for each image. So again, if you have the files in front of you, you can see what the file size is, but if you haven't downloaded them and you get that answer wrong, then you're sent back to a copy of the download instructions, hopefully to actually do it the second time if something was missed the first time.
I wonder if the students know how to count the number of files.
That's a good point. I hadn't thought of that, and I had assumed that students would be able to do that easily.
But now I just selected, I didn't download them, so I still have them in the drive. I selected them and it says 50 selected. Okay, but there's no other way to see how many. I don't know. I'm just asking if they know how to count them, because they're not ordered. They don't have like 1, 2, 3, 4, something like that.
Yeah, but maybe something as simple as adding some a sentence like, if you select all of the images, you'll be told. Well, I guess it depends on platform once it's once they've downloaded it, but I think both on Windows and Mac,
I
It
use
just
mine,
tells you once
so
you've selected it.
I'm not sure. Let me see.
Well, and then the other question that that came through, apparently there's a problem with the form accepting responses. It's something to do with the file size that I've I haven't yet resolved that. So because it's not working, don't worry about using the form to send an update because that's not working. But if you're not shy to share a screenshot in the chat, or just to simply mention in the chat what activity you've gotten to now, so we have an idea of where people have progressed to. So anyone who's not too shy to do that, either activity number or screenshot of where you've gotten to in the chat, please.
Bom, como é que foi o primeiro dia de férias? Hã? Tens uma formação? Opa, estou sempre ocupado.
Okay, now let's ask for another update. So again, either by a screenshot or writing in the chat, and either public or private message to me if anyone prefers that. Let me know where you've gotten to by this point. And I think we'll only take a couple more minutes, so you won't have time to get through the whole scenario, but a couple more minutes.
Michael,
Yes.
when we trained the model the first time, then it asks to sort of a test and to use test images folder. In principle, you didn't download the test images folder. No?
Oh, isn't the test images also within each of the
In the drive, it is, but it's a link, you know?
oh, so it
So
it
it
doesn't
doesn't,
download properly
no.
there.
Yeah, I always thought it would, but no, it doesn't download. So you don't have the test images there.
Okay,
Mhm.
I would have thought it would. So yeah, I should add a link
Mhm.
to that point because if it
The
didn't
link
download for
is
you, then
there,
it
but
didn't download.
as a link, I don't think it downloads. And it makes sense because if you link something to a huge thing, it shouldn't download the link, right?
Yeah, yeah. No, that's a really good point. So that's the analysis one, right?
Yes.
Okay. So as a fix for people going through that now, I'll put a link in.
It has already tested. That's the training.
Oh yeah.
Verification of training, yeah. Good.
Okay, and we're hearing from a couple of people who have to leave, but got to the analysis. So yeah, you can definitely pick up on it later, even though we don't recommend students doing that because it can mess with the timing. As a teacher, yeah, you can pick up, and like I showed you at the beginning, instead of going to restart, just start. It should start you again from where you'd saved. And of course, with the teacher access, you can go behind the scenes and like in the authoring tool to look at the different parts. If for whatever reason it doesn't work in the student view to get back to where you'd saved.
And this is a student view, so it's not a link to any account. So this will not count as an implementation. It's just
yeah,
yeah.
that as well. Yeah. Because it's not a student account, it's a teacher account.
Yeah. And I had to go also.
So I think with that, and those who we heard from had all gotten to the analysis phase, so that should give a pretty good feeling of what the scenario is like as students work through it. So I'll stop you now. If you haven't worked through the whole thing, we encourage you to work through the rest before trying it with students, so you know what to expect for them. But I'll start sharing my screen again to take you through a little bit more quickly through where it's going with the model, and then a couple of other things like how this relates to machine learning models as a whole, and how this actually relates to Discovery Space, and one of the reasons why we're so eager to have you implement it with students more. So I'll start sharing my screen again. If only I could find my Zoom controls. The problem resizing everything, it's always hard to keep track of where things are. Okay, so you should now see my screen again. I'm in the authoring tool. I'm going to go back to the overall view for a second. Okay, the overall view or the map. So those of you who made it to the analysis phase, you were at some point here where you were training the model, and I'll go through a much quicker version of training the model to give you an idea of the different with like where it's going. So most of you got to a point where you have spiral and elliptical galaxies, and you're training it with more windows. Okay, training with data sets. I guess you're just seeing my browser. You're not seeing my folder of images that I'm gonna bring it through from, right?
Right. We can see your browser, so loading sample. It has loaded.
You can see I've loaded now spiral galaxies and now 50 elliptical galaxies. And going through training the model. And it's worth noting, and that's one thing students are asked to take note of, the time it takes to train models. Also notice it says don't switch tabs. And unless you understand a bit about where we're going with machine learning, you might wonder, well, why does it want me to switch a tab while I'm doing that? And one of the reasons for this is because machine learning models take a lot of processing power. And so it takes a while. That's why it takes a while to train, because there's only so much processing power allocated to it. And Google doesn't want it, like Teachable Machine is a Google product, doesn't want you to give it a big job, take up a lot of its processing power while you're doing other things in the background. So if you leave the tab, your training will be given very low priority, and it can take hours to train something very simple. And so once you understand a bit about how much processing power machine learning takes, then that makes sense. So once it's trained and through the analysis phase, you don't use any of the advanced models. Oh yeah, I can't turn on my webcam while it's being used for Zoom. but I can use for a file. And so then I'll go through testing different images from the test image folder. And then it'll say with a different amount of confidence. In this case, it is an elliptical image I used, so it was correctly identified with a high level of certainty, 98% certainty. And I'll put a couple more. That was another elliptical correctly identified. And then I'll try with a couple of spiral galaxies. Correctly identified. And so we can see from this, the model's pretty good. So far, I've done with 6, 7, all correctly identified. And so if we go through it, and 10 is what's, oh, this is down to 87. So correctly identified, but not that confident. So in the context of this activity and students making a results table of how accurate the model is, they're asked for the number of correct identifications with 90% or more confidence. So this is less than 90% confidence. That was the 9th one I tried. Now, 10th one. Okay, so that was 9 out of 10 on our accuracy model for that. Then the next thing they're asked to do is change the number of sample images. So if I get rid of most of these, and I'll get rid of all, I could clear the class, but it's easy enough to just click through. So I'm down to 10 spiral galaxies, and I'm going to get down to 10 elliptical galaxies. And hopefully it's not hard to guess that with less, only 9, that's okay, I'll leave it at 9, and I'll train the model with 9. And we should see it'll be a little bit quicker to train. Not that it was that slow with 50. And the accuracy should go down. There's a bit of a bug in Teachable Machine. To upload files again, you need to toggle the input on and off, or switch to webcam, which in my case won't work. And then it's a permissions thing that happens on a lot of computers, not all computers, but everyone I've used it on. So if that comes up, just have students toggle it on and off. Now let's try again with a couple of galaxies. So far, so good. But we should see once we test enough galaxies. Yeah, like this one, incorrectly identified, not even lacking confidence. And that was the 6th one I tried. So far 5 out of 6. Incorrectly identified again. So we're now 6 out of 8. Up. Also incorrect and lower confidence. Incorrect identification. So 6 out of 10 identified correctly. So the model is okay, but it's not particularly good. And so that's the core of the analysis part of this. They're analyzing the effect of different data size or different sample set. And when you hear people talk about artificial intelligence, they're always talking about the data. How much data can we get? We need more data to train on this. And you've probably heard us talking about this last week and this week as well. We need data from people using the platform to train the model of Discovery Space. So the amount of data that's being used will affect the quality of the results. So before I go on to the advanced training options that are covered in the reflection phase and kind of more advanced reflections, are there questions about what I've just shown, or like up to this point and how it works in the scenario, how to explain it to students? I'll give a moment to see if there's anything anyone wants to ask before I move on. Doesn't seem like there's anything, but again, don't be shy if you want to interrupt with anything. And so going to the next part, or like what's covered in the reflection phase, is getting into the advanced options of the training. And before I do that, and if you look through, if we look back to the scenario, what it says with the advanced training is to start with 50 images, because just like any experiment, we want to change one variable at a time. So in the previous phase, we were changing the number of images in each class that it was being trained on, and we left all the other options the same. So all the other variables were being controlled. We were only varying the number of test images. Now we want to go back to 50 images per class, and we're going to play with the number of epochs, which is this advanced option. There's other advanced options. They're not covered by this learning scenario. They're less instructive to manipulate. I'll briefly explain them afterwards, but we're going to focus on the number of epochs because it's the most useful thing to do. So I'm going to manually clear the rest of this data set and then load all 50 images. Maybe I can't delete it to be empty. Yeah, I can make it an empty data set. And I'm going to reload all 50 of them again, and then play around with the number of epochs to show what students will be taken through. So, okay, here's my, elliptical galaxies. Let's upload a whole set of elliptical galaxies. Hopefully I got all 50 here. Excellent. So 50 elliptical galaxies populating that that data set, or that class. Now back to the spiral. All 50 back in there again. Oh, it's just one. Okay. There we go. 50. Okay. So now the advanced options, the number of epochs, and the number of epochs are the number of passes through a training set. So in an image classifier, and I've got a couple of slides to explain what's going on here, but behind the scenes. But in an image classifier, it passes each set of images through the model, and then does that again, and then again, and again. And each pass through that is called an epoch. The batch size is the number of images, or the number of things, which in this case is images. Here it's 16. So what that means is from the 50 images here, it takes a subset of 16 to train the model on the first epoch. The second epoch, it randomly selects a different 16 images through the next epoch, then repeats this random selection of 16 of, like a batch of 16 of the 50 for each epoch. If we only had 10 images, then the batch size 16 is the limit, but it only uses 10. Varying the batch size has a less direct effect on the training, so we don't bother doing that right now. And the learning rate is how much it changes during each epoch. Again, that's a bit of a messier thing to deal with, so we won't deal with that. The number of epochs, I'm going to bring this all the way down to 5, which is very short. And notice how quick it is to train the model. So there's the preparing, which is getting it ready, but the actual training took less than a second. And then when we go to actually use the model, it's sometimes surprising that it actually correctly identifies sometimes, but it's generally a terrible model when it's been trained that quickly. But notice on the savings on processing time. So depending on what you're looking for in a model, it might, I mean, you wouldn't want to go as low as 5, but you might want to play around with things a bit. So here I'm testing an elliptical galaxy, falsely identified with a lot of confidence, correctly identified with fairly low confidence, falsely identified but low enough confidence it really doesn't know what we're looking at, and then a couple of spiral galaxies, incorrectly identified. So we can see the results when it's trained on that few epochs is just garbage. Now let's bring it up to 200, and in the learning scenario, students are asked to do it for 100, then 200. I'm not going to bother showing you each of them separately, but just to skip to 200. And we can see it's a lot slower going through. And the time per epoch is about the same, regardless of how many epochs you have. Often, the last part of the training is a little bit quicker because the model is like correctly identifying, and each epoch looks at what it gets wrong and tries to correct that. But it's about the same amount of time per epoch. So 200 epochs, about 4 times as long as 50 epochs, slightly shy of that. So again, toggling input on and off until it's ready to accept. And now let's see if it correctly identifies, yep, spiral galaxy, 100%. Oh, that's surprising. That's a false identification. Huh. I'm surprised at, I'm going to train it one more time because on 200 epochs, unless there's a problem with the sample images I've used, it shouldn't be that bad. Like it should be getting it right at least 9 times out of 10, if not more often than that. Well, just to show what I meant by switching tabs. So notice we're coming up to 150. I'm going to switch tabs, wait 10 seconds, and we'll go back there and it'll still be at 150 or maybe like 152, 153. But it slows to a crawl because it's gotten low priority in processing power. Oh, it got up to 160, but it was a lot slower. Okay, again, toggling the webcam on and off, and hopefully, okay, first one correctly identified, lots of confidence. I'm going to need to look at this sample set because this is odd behavior here. That it's not that, yeah. Yeah, that seems really funny. Normally, once it's trained at 100 or 200 epochs, even on just 50 images, it's quite a good model. I'm not sure. We won't dwell on that. Let's see if there are any other questions before I briefly explain what the model is doing and how this relates to Discovery Space as a whole. So any other questions up to this point? Doesn't look like it. So getting back to these slides to explain sort of what's going on behind the scenes. And again, these slides are shared with you. So if this is of any use to explain to students what's going on, feel free to use them as well. These were prepared by a friend of mine, Kalina Dimitrova, who co-hosted AIMLO, Artificial Intelligence and Machine Learning Online Workshops, a different webinar series we ran in the fall. And she's a particle physicist specialized in readable AI. And so here we're looking at what an image identifier does. And we did this with cat and dog pictures. So there are different filters. Here is randomly looking at filter number 26, which is looking at edge effects. So we see where there's a difference between colors, like the contrast of the blue collar and the rest of the dog. That comes up as yellow compared to the background. So it's essentially adding noise to a picture so that we're only looking at certain elements of it. And each epoch of a training will pass through a number of different image filters. And it'll be looking at just part of an image or some aspect of an image. That allows us then to make something called a saliency map, which is points that it has in common with the class that it has. So if we look at dogs, where we see the most red, we can see these points at the back of the leg, which is it's like the upper claw, like the thumb that's pointing backwards on a dog. We also see this phantom identification of a tail. In this case, the curve of the person's shirt looks like what the algorithm would have thought of as a tail. In this case, it's not correct. And the ears are another like key feature that distinguished it. Whereas the cat, we see cat eyes are distinct, and the whiskers in this case. We had some fun running through a bunch of different images. I'm going to skip through to not like dwell on too many, but two of my favorites were, we trained this algorithm on dogs and cats. And if we look at this filter is an edge filter. So it just looks at the edges where there's a change in color, which in this doodle, that's kind of the essential part. And then with the saliency map, we see that from the dog's nose and how the legs connected, even this pretty crude doodle was correctly identified as a dog. With a cat, we see the edge filter shows the brick wall, the whiskers, the ears, but the saliency map, the wall doesn't show up. There's no red and yellow points because that wasn't something identifying it as a cat, but these ears and whiskers and these claws were. So it's interesting to look at how the steps of an identifier work. This, of course, is beyond the learning scenario itself. The learning scenario just takes students through training the model with teachable machine. But like this is a little bit more advanced than that. So now that I've been using terms like epochs and data set size, then let's very briefly look at a language model and how a language model works. And a language model works, the most basic step is by predictive text generation. There's a lot more layers or steps to it on that, but here's a map of word frequency in the song American Pie by Don McLean. And so it's a very famous and fairly long song, so it's got enough data to train on. But if we look after the word the different things that could be said, it could be the levee, the day, the music, or the day the music died. So this is a tree showing all the possibilities. Now, I said we'd get back to Discovery Space, and I'd show you something about how Discovery Space works. So if we go back to the dashboard, remember all the way at the beginning, I said, oh, I'd get back to the dashboard at the end. Now I've gotten back to the dashboard. So some of you had said you tried out the mission to Mars scenario. So I'm going to look at the mission to Mars scenario. I'm going to have a terrible time trying to find the mission to Mars.
The fourth one, the third one, fourth.
From
where you were.
Oh,
down
right, okay.
there.
Okay, mission to Mars, and I'm going to set an arbitrarily wide series of dates just so we have some data from this. So including up till to today itself.
Yeah, you can put today directly. There's the word today.
Oh.
There. If you
Okay,
go to
well,
the
but I
calendar,
selected today.
Yeah.
Okay, so if we apply it, then it's going to generate a chart showing different use of Discovery Space. It takes a moment to generate this data. Okay, some of the data is already here. So we can see the number of correct answers, incorrect answers per phase. I'm really interested in is this, which is this isn't much to visualize. You'll see in a moment. But remember how we were training in teachable machine and we said, well, if we change the amount of data, then we can have it better identifying. That's what, oh, here we got more things. And here, which should come up momentarily, will be a list of different pathways that students have taken through the scenario. That can be used in the same way that this list of order of words is taken. And when creating a language model like ChatGTP or Microsoft Copilot or DuckDuckGo, what that Duck AI, Mistral, which is a French produced one. There's all kinds of different models. But they'll be looking at words or word combinations, because when you're stringing things together, sometimes it might not make sense to have a single word. It might be like one word might always be followed or preceded by something. If you're thinking about like spelling in words, the letter Q in English is almost always followed by U. And so if you were looking at letters in a word as a token, QU would make sense as that would be the sensible way that Q would occur. So a token doesn't need to be a word. In this case, on the paths followed by students, and we see there's different paths, and like we can show more the different series of activities done by students. And so once enough students have gone through it, that all possible paths have been followed, and some pop up as more frequent than others, then there can be a frequency map that gives a weighting where the algorithm can predict with what probability students would go about the next activity, and thus create a model where it expects, based on a series of answers, where the student is likely to go, and in that case can predict or propose the next activities for a student, in some cases even before the student has entered an answer. So that's the predictive part of AI. The other part of it is, if you remember back in Student View, we have a chatbot, Plato, that guides students through it. So chatbots are a very common application of AI. There's a lot of already off-the-shelf packages available for customer service on AI. If you write to a company and they have a service hotline, or if they have a service like WhatsApp or Facebook, then often the first layers of it will be through a chatbot like that, where it's been trained on user data and it interprets the language that you give. So rather than, well, and I'll go back to Student View and go back to Plato to show clicking on something. So rather than having buttons that we can click on, like yes, continue, then it's fairly easy to import a language model. So any affirmation I give, like if I say, let's go, or I'm ready, or show me the next thing, then rather than clicking on predefined buttons, it can interpret language and interact with the user as such. So that's like those two elements of it are why, for that functionality to be in place, we need to have usage data of how students make it through the scenarios, which then gets back to the final point I want to remind you about, both the implementation challenge, where you could win a trip to Greece if you help us out with enough student implications, but also next week's webinar. So next week's webinar, the observations of Galileo, that's going to be presented by someone at our partner, Elena German and Iki Agogi. And like usual, they've been pretty slow getting back to me, so we don't actually have the date and time set yet, but that should be set any day now. And then anyone who signed up for the mailing list will be told right away. I think anyone who followed this webinar as well, I'll send you a link to the recording afterwards in case you missed anything, or to relive the magic of seeing me talk. And I'll include a link to register for the next webinar, as long as we actually have the date set by then. So that was the last two things I wanted to say. That brings us to the end of this hour-and-a-half webinar, which included time to try out the scenario for yourself. So thank you for joining us, and thank you for your patience sticking around till the end. If there are any remaining questions, I'll stop the recording and I'll stay on if there's more things that anyone wants to say. But yeah, so with that being said, thanks for joining. I'll turn off the recording now.